What's up? You're watching Swifty, and in this episode, we're going to go over strong reference cycles for closures. And the example we're going to cover is one where we're going to create an HTML element. And if you don't know HTML, that's okay. Pretty much what this object is going to do is it's going to take a string and return a reformatted string. All right, so let's create this class called HTML element, and it is going to have a name property of type string, and it's going to have a text property of type string, and we're going to have an initializer which will take a name of type string and then a text of type string, and we're going to give it a default value of a blank string, and this will make it so that when we initialize it we don't have to give a text if it's empty. So we're going to assign this argument value to the name here, and we're going to assign this argument value to the text here. We're going to go self.name to access this variable and then assign it the value given from this parameter, and then we're going to go do the same for the text equals text. So this has an initializer, and we're going to define a property that has a value of a closure. So it's going to take nothing, return a string, and it's going to be equal to a closure right here. It's a pretty simple closure. It's just going to return an HTML tag, and it's going to take the self.name, and it's going to take self.text, and it's going to take self.name, and it's going to backslash right there, and that is the tag. It's going to say use of unresolved identifier self, and the reason it's saying that is because all properties must have a value before the instance of a class can completely be created. So as properties are being created, it assumes that the instance of this class is not created yet. So the way we're going to get around this is we're going to call this a lazy var, and what that does is it says this property doesn't have to be created until it's attempted to be accessed, and it can't be attempted to be accessed until there's an instance of this HTML element. So the compiler knows that self will be available because of that. Let's say you wanted to create a paragraph, so var paragraph equals HTML element, and we're going to instantiate it, and it's giving us both options. We're able to instantiate it by just giving it a name because we gave a default value for the text, or we can give it a name and the text. So we're going to give it a name and text. We're going to name it P for paragraph, and we're going to give it the text as hello. It's very profound, I know. We're going to give this a dinit keyword so that we can keep track of when it's deinitialized. So dinit, and then we're going to print HTML element with name. Oops. Self.name is gone. And we're going to set this paragraph to nil. And as you can see, when I assign nil to the paragraph, it deinitializes. Surprise, surprise. Actually, there's no surprise there. This will be the surprising part. I'm going to call the closure property, and you will see that it's no longer being deinitialized. So when I comment this out, it's deinitialized, and when I don't comment it out, it's not deinitialized. And so what's happening here is when we use self in the closure property, we are quote unquote capturing self. The closure is a reference type, and it holds a strong reference to the instance of a class, and the instance of a class, because this is a property, holds a strong reference to this closure. When paragraph is set to nil, the closure itself holds a strong reference to the instance that paragraph was pointing to before it was turned to nil. So there's a memory leak going on right here. Instead of using a closure property, we could just change this to a function. We can do func as HTML. And the interesting thing is that functions do not quote unquote capture self. So functions cannot form a strong reference to the instance of HTML element. Var lazy var. All right, so after the compiler defines this HTML element class, we get to line 20 and it executes the right side of the assignment first, sees that HTML element initializer is being called. So it jumps through line 11, goes to line 12, passes in the name as P, passes in the text as hello, and then assigns the values to these two properties. An instance of HTML element is created and assigned to paragraph. So now we get to line 21, checks if there is a value stored at the paragraph, and there is the HTML element instance. So then as HTML is attempted to be called, and because it has a lazy here, now it creates this closure, and closures are first class reference types. So as HTML closure is created, it captures a reference to HTML element, and it is assigned as HTML. So HTML element gets a strong reference to it as well. Then on line 22, paragraph is pointed to nil. And as you can see, HTML element is not deallocated because there's a strong reference to it from the closure. And the closure is not deallocated because the HTML element has a strong reference to it. Just for fun, I'm going to print out the HTML element that's created. All right, and I'm going to show you what this is like if we comment out the print. So, all right, so it's a lot simpler. After line 20, we create this HTML element and we have the paragraph referencing it. Then paragraph is pointing to nil. There are no strong references on the HTML element, and then HTML element will be deinitialized.